what kind of inventory level that we need to maintain. So that is, if we are interested, what is the maximum inventory level, what is the minimum into inventory level we allow, so such things. And then purposes of inventory. So one of the major purposes of inventory is to maintain independence of operations. So for an example, if we can keep inventory between production processes can function independently. We saw this thing in the previous lectures on process analysis. And then to meet variation in product demand. So when you see demand may go up, when it goes up, you can supply from the inventory. So that is one of the major things. And so to allow flexibility in production scheduling. So certain orders, we can schedule if we have inventory, because let's say if you get orders that need to be prioritized, so that existing orders you can supply from inventory, so that you can have priority changes. And to provide a safeguard for variation in raw material delivery time. So raw material delivery time, there may be delays in delivery, and also there may be delivery time delay itself. So when you say lead time delay and also lead time, variation in the lead time and also delay. And to take advantage of economic purchase order size. So when you purchase large quantities, you are likely to get a lower price. So this is another thing. Actually, in our country, people are keeping inventory. When your local currency get depreciated, in such situation, keeping your assets in the form of inventory is uh, is much safer. So those people who who keep their assets in inventories in a country where currency gets depreciated. So the currency depreciation can happen, let's say when the government prints more money than what it can, what the economic system can absorb without price changes, then that is one of the ways of the depreciation. And this is internal depreciation. External depreciation can happen, when your imports go up. When there's the higher imports relative to exports. So in that situation also, your currency can get depreciated. And in 1948, when we got the independence, British pound was around 5 rupees. Now it is, I think, near 300 range, maybe more. So, and then, gradually our currency got depreciated. So people then, keeping inventory, investing in assets is much safer. So keeping certain amount of money in your pocket for day-to-day affairs And then the balance in assets, I think, is a wise idea. So that's maybe, you see, it may be why in our country, uh, motor cars are expensive, very expensive. And then houses, how, especially in city areas, houses are expensive, land's expensive. So you see, it's because people are, one thing is people are investing in those assets. The other thing is uh, the people are migrating to city to find prosperity. So that is another thing. So when it comes to inventory cost, you have holding or carrying cost. So this part involves, cost of storage, handling, insurance, etc. Actually, cost of carrying, the major component is opportunity cost of capital. Capital is the most major component. And they set up for production change cost. So cost of arranging specific equipment setups, etc. We call it setup cost. And then we have ordering cost of someone placing an order. So when it comes to ordering cost, you have two types of cost. One type cost is called header cost. This is cost of ordering from a particular supplier. Then there is another component of the ordering cost. This is line cost. Cost of ordering a particular item. So you see, if you are ordering, let's say 3 items from one supplier, so then you have, let's say when you order 3 items from one supplier, you have one header cost and 3 line costs. So within bracket, let's say n items from one supplier, you have one header cost, and so in this case, in general, n line cost. So if you are ordering, let's say 5 items from one supplier, then you have one header cost and 5 line cost. So for each item, there's a separate order cost. So when you add up, header cost to line cost, then you get the header cost is similar to like fixed cost of capital, fixed cost, in production scenario. So it distributes among particular items. So you see, when you calculate the total order cost for a particular item, then maybe proportionately, like depending on how many items you order from the supplier, so you can distribute the cost among the number of items evenly. And then shortage cost. Cost of canceling an order. So this is actually, shortage cost, we have two types. One cost is cost of canceling an order is one thing. Cost of back order is cost of canceling an order and cost of back order. See, when an order is cancelled, so we can easily calculate, let's say the lost sale, cost of lost sale. But when the order is back ordered, the shortage cost is financially, it's difficult to calculate because you get the order back ordered, so that you don't lose your order, but the customer place an order and then customer wait until the order is supplied. So then the possibility is that customer may not order in next time. So that is one thing. And then the back order situation, there's one of the dangers is that you pay and then wait. So and then there's so you see, when you receive it, it may not, there may be variations from what you wanted and then what you ordered and what you received. For an example, it is very common nowadays when you place orders online, you don't get exactly what you expected. So this is the similar situation. Inventory systems, you have based on the demand pattern. So demand may be for independent or dependent. Independent demand, we have models, fixed order quantity models. So you have fixed order quantity models, we call it EOQ models. So EOQ stands for economic order quantity. And then you have fixed time period models. And so EOQ models, with discounts, so with differential discounting, with safety stock. So safety, you see a model with this is EOQ with intentional shortages. So you allow a shortage, pre-planned shortage. Okay, you allow a maximum allow you leave a maximum allowable shortage. So then we call it EOQ model with intentional shortages. Okay. And then when the demand is dependent on a particular item, for example, the demand for material depends on the demand for end item. Demand for end item is in the category of independent demand. And when you have the demand for independent item, the material that is required to produce that particular item, end item, you can calculate using material requirement planning, just-in-time systems, hybrid MRP, MRP jet system. So these things we can use to calculate demand for materials. So back ordering cost, back ordering means customer place an order. An order because item is not available at the point of order. That could mean customer place an order because item is not available at the point of ordering. Customer place an order and wait for delivery later because item is not available at the point of ordering. So this is what what is meant by back order. And then you see we're going to discuss fixed order quantity models. So you have assumptions. Demand for the product is constant and uniform throughout the period. The lead time is time from ordering and to receipt is constant. Price per unit of product is constant. Inventory holding cost is based on average inventory. Ordering or setup costs are constant. All demands for the product will be satisfied. That is, no back orders are allowed. So fixed order quantity model. So this is called basic fixed order quantity model. See, you have, in this axis, you have on-hand inventory in units, and this axis is the time. Uh, let's say let's say you place an order here, order is received here, and the moment you receive the order, inventory level go up by that quantity. This is order quantity. Uh, so, the slope of this line is the inventory depletion rate, that is demand rate. Okay. And then from here to here is what we call one inventory cycle. So the order placement happens, here at this point, in the time scale here. And then order is received here. The moment order is received, the inventory level go up by Q. If the order quantity is Q. So we place the order when the inventory on hand reaches R is called reorder level. We place the order. So this is where you place the order. In terms of inventory level, it is 3R. In terms of time, it's here. So fixed order quantity model. So you see total cost equals DC. D equals demand. C is the unit cost of item, unit price of item, and then Q is number of orders. S is the ordering cost, and Q over 2 is the average demand. H is the holding cost. So, and then we see as a graph, we have ordering cost. Ordering costs go down when the order size become larger. So in this axis, order quantity, this axis, the total cost, the cost, okay, in the vertical axis. And then order cost go down when order quantity go up. And then holding cost is go up proportionate to the order quantity. So that's why you have a straight line like that. So this is, let's Q over 2H. So the slope of the line is H over 2. So this is H over 2. And then slope of this line, red line, is H over 2. And then you see, so when you add up this ordering cost to holding cost, you get a total cost function. The minimum point of the total cost function, we call it optimal order size or economic order quantity. So using calculus, actually we like calculate this thing because so this is one, okay. Without shortage, let's say, let's consider complete the syllabus, the verbal part. So using calculus, we take the first derivative of the total cost function with respect to Q and set the derivative or slope equal to 0, solving for the optimized cost to minimize value of E of Q. So you get Q optimal D 2ds over H. So that is 2 times annual demand times order quantity or setup cost divided by annual holding cost. So reorder level equals R equals, we see D is average daily demand, L is lead time. So D times L. And then inventory is you got raw material, in process, and finished goods. Functions of inventory, you have smoothing or the irregularities of supply, minimizing the production cost, allowing organization cope with perishable materials. So inventory decisions, we have when to replenish the inventory of that item and then how much to order. Cost trade-off, find the trade-off between carrying cost and ordering cost. So then models for inventory control, we have without shortages, purchasing model with instantaneous replenishment. So this model we call, this is the basic EOQ model. So this is basic production model. And then with shortage, we have purchasing model with instantaneous replenishment with shortages. So this here, this shortage, here shortage is intentional. So here manufacturing model also, here shortage is intentional. Out of these models, we will discuss the first one, second one, and I will give you the answer for the third one also. Fourth one is tough. So we will study that in the production planning lecture. No. Oh. I will. So then, without shortages, purchasing model with instantaneous replenishment. So we have decision variables. Let's say this is basically open. EOQ model. That I showed you earlier. So decision variables you have, D is annual demand in units. And then CO is cost of ordering one order per order. CC is cost of carrying a unit per year. Okay, so this is cost of carrying a unit per year. Remember, this time dimension is very important in calculation. C is purchase price per unit. Q is order quantity. R, let's say equals the order level. And then it's say tau equals lead time. So now you see we have let's say the time of one inventory cycle is T, order quantity is Q. So then we have to compute without shortage purchase model. So the number of orders per year equals D is the annual demand divided by number of orders per year is DOQ. So annual demand divided by order quantity, when you divide the demand by order quantity, you can calculate number of orders required to meet the demand. Then average inventory is Q over 2. average inventory, how we get that? So let's say the area of one of the triangles, let's say here, you know, this area of this triangle, one triangle, is the inventory per cycle equals, you see, you can so this equals R times the area of one triangle. So this is Q multiplied by T. Okay, so then this equals, so then, you know, the slope, you see, slope equals Q, see, Q divided by T. The slope is D. Slope equals D equals Q over T. So then, you know, from this we get T equals Q over D. Q over D. So you see, and then from here, you know, we can get, you know, this one. T equals Q over D. Okay, so then this equals So then the inventory per cycle is Q square divided by 2 half Q square divided by D. That is inventory per cycle. So then, inventory per year equals. So then, you have inventory per cycle, this one, multiplied by number of cycles in the year. Number of cycles in the year equals D over Q. This equals D over Q. So when you simplify this, you get Q to 2D. Okay, so then, sorry, Q over 2. Because here, one D cancels with D, one of the Q's cancels with the other Q in the denominator. And then the Q in the numerator and 2 in the denominator. So this is how, this is the average inventory per year. So this is how, we got this average inventory per year. Inventory per year, we got this thing, this particular way. Not, you can't just divide, you can't divide the order quantity by 2, okay? So if you, by dividing order quantity by 2, you can't get the average inventory. This is valid for only this question, this situation, but in other situation, average inventory is not equal to Q over 2, it's different. And then, so we found the average inventory per year, okay. So that's how, we got the average inventory equals Q over 2. Cost of ordering equals, you see, number of orders per year is D over Q multiplied by CO. Cost of carrying equals Q over 2, that's average inventory, times cost of holding a unit in the inventory per year, that is CC. Purchase cost per year equals D is the demand multiplied by C is the unit cost or unit price. So then, so total cost per year equals D over Q CO plus Q over 2 times CC plus DC. And then, when you differentiate with respect to Q, that is, D TC over DQ. So when this one is differentiated, you get minus D over Q square times CO. When this one is differentiated with respect to Q, you get CC divided by 2. Okay. And then second derivative. First derivative is this one, second derivative becomes 2D over Q to the power 3 times CO. So for positive Q values, this is a positive number. So therefore, whatever the value we found positive in this solved in this equation, we get for that particular value, we becomes a minimum. So then, since the second derivative is positive, we get the minimum for Q. So the minimum for Q is is obtained by solving minus d over Q square times CO plus CC over 2 equals 0. And then when you simplify, let's say you can take d over Q square times CO to the right hand side and then cross multiply. Okay. And then, Q square equals 2 COD divided by CC. And when you get the square root of it, so square root will have positive and negative two numbers, but then the order quantity can be either 0 or positive. So you see, we only consider positive value. So the optimal order quantity DCOD time divided by CC. And then optimal number of orders equals D divided by Q star. And then time between orders is Q star divided by D. Okay, so this is the proper way of calculating this answer. So if you have questions with regard to this, I can help you.
Sir, can you please explain time between orders?
Time between orders is, is T. Okay, is T. You see, you got the slope equals Q over T. So if you look at this triangle, this height is Q. The foot of the triangle is T, and then Q divided by T equals the slope of this slope. Okay, so this is the rectangle. Opposite of the rectangle, you have this line. This line slope, you calculate by Q divided by T equals the slope. Okay. So then, so then you have the slope D equals Q over T. And then from this equation, we find T equals Q over D. And then for the optimal value, so you substitute the optimal value here in the Q star. And then optimal T is equals Q over D. So that's how we got this Q over D. Time between. So
Thank you, sir.
Actually, this is optimal time between orders. This is optimal number of orders. This is actually then I'm moving into the manufacturing model without shortages. So in this one, we have CO means yes, cost of ordering a unit. So the height of this line equals maximum inventory level, I max. Height of this line. And then slope is D. Okay, so now we have so when you see one inventory cycle starts here, the time of one inventory is starts here and then the cycle ends here. So the inventory cycle equals let's say T equals plus into one plus into So the inventory cycle, so the inventory cycle equals from this corner to this corner is T1 plus T2. So inventory cycle equals T1 plus T2. So here, from the beginning to the maximum inventory level, reaching maximum inventory level, this part, this T1 equals actually production time. And if we slope of this line equals T minus D. Slope of this line equals P minus T. Slope of that line equals D. So from during the production, you have you are producing at a rate of P per year, and then at the same time, you are selling at the rate of D per year. So, and then inventory accumulation rate is given by the slope that equals P minus D. So then, so P is production units per year, T1 is production time, T2 is non-production time, C production cost per unit, and other variables as in the previous model. So then you see cycle time equals T1 plus T2. Production time T1 equals Q divided by P. So in order for this to be clear, I will write it this equals Q divided by P. Okay. So then production time equals QOP. Average inventory per cycle. You see, we have, we need to calculate the slope of this triangle. Slope of this triangle equals half times I max, the height, times the foot. Foot equals T. So then the average inventory per cycle half times T1 plus T2 times I max. And then, I max equals, by considering the first triangle, I max divided by T1 equals P minus T. So then I max equals T1 times P minus T. T1 is Q minus Q over P. So then Q over P times P minus D equals I max. So that's how we get I max equals Q over P times P minus D. So then average inventory per cycle equals half times T1 plus T2 times I max. On the other hand, this T1 plus T2 equals T T equals Q over D. Okay, T equals Q over D. Therefore, for T1 plus T2, we can substitute Q over D. And so when you see the average inventory per cycle equals so this quantity so this one equals so if you can calculate this way, this in a is equals R times T1 equals QB plus T2 equals Q over D. Sorry, Imax. This is Imax. This Imax is this amount. Times Imax. Okay, so then when you simplify this one, this equals R times so you can take I max square out here. To the power 2 divided by 2 times 1 over p plus 1 over d. Mm, So this one becomes actually P1 equals our I max divided by P minus D from this triangle I max T1 divided by I max divided by T1 equals P minus D. From that you get T1 equals I max divided by P minus D. So then this is minus D. This is 1 over D. So when you simplify this, you get so you can use common denominator as T times P minus D. Common denominator. The numerator you can have D plus P minus D. So then, and then this has to be multiplied by this quantity. So then this equals when you simplify it, so this one of this D cancels out with one of the D's. cancels out with this, plus D cancels out with the minus D. So in the numerator, you will have P remaining. And then, so on the other hand, we calculated Imax equals Q over D times P minus D. Okay. So then Imax equals Q over D. So we calculated Imax here. Q over P times P minus D. So then we substitute that quantity in this one. Q over P times P minus D. Maybe it's better. Imax square. So Imax is we can come here. Q over P times P minus D. Yeah, see. times square. So MX equals QOP times P minus P to the power 2 times half times this quantity.
Recording in
We
progress.
have Q square, so Q square will remain. Q square times P minus D will remain. Q square. And then here in the numerator, P will remain. P times D. One D remains here. One of the P minus D cancels out here with this P minus D. One of the P cancels out with here. There are P square. So then this is P times D. So this one. So this is the average inventory per cycle. So then average inventory per year equals, we have to multiply this quantity by P D over P. So we multiply this one D over P. Number of cycles in the year is D over Q. So then, when you simplify this whole thing, one of the D's cancels out one D. One of the Q's cancels out with this Q. So then what will remain? So this will become Q. P minus D remains, and D cancels out with D. So that's remain. So this one equals Q over 2 times 1 minus D over P. So this is the average inventory per year, Q over 2 times 1 minus D over P. So when you divide by P, the whole thing, you get so when you divide by P, this one, you get P divided by P is 1, D divided by P, D divided by P. See, so that's how we get 1 minus D over P. And Q over 2, so Q we take out, so Q over 2. So then this is average inventory per year. So now that we have found average inventory per year, and then we can calculate the cost, the total cost. Total cost equals plus. So then, T over Q, that is number of orders in the year times, and then CO plus DC DC plus H times, so which is CC times BC times CC times CC times average inventory per year we take from here. This is what total cost. So when you differentiate, equals minus this one. When you differentiate, you get plus. This you get 2 times two square plus this thing is q. It's only one. Q becomes 1. The other things remain same. So, and then when you simplify this one, here the second derivative is going to be positive. So when you simplify this, you get q square equals q. Q square equals 2 d this here divided by CC times 1 minus d over p. So then Q optimal, let's say it's Q star. Equals square root of Q star. So this is Q optimal. So, and then optimal time between orders, optimal time between orders equals Q star divided by D. And then optimal production time equals Q star over P. Optimal production time is Q star over P. Optimal time between orders is T actually. So this is T. So this is T1. Okay. So this is what we have given in the formula. So this one is okay. So this is the answer for Optimal time between orders is T Q star over D. Optimal production time T1 equals Q over D. And this is what we have given in this is the same thing we have given here. So purchasing model with shortages, you have a maximum intentional shortage level of S here. So then let's say shortage cost per unit per period, CS, economic order quantity, I max maximum inventory, S max is maximum shortage. So then the answer is given here, this one. So these are answers. So this is this is the maximum, the optimal inventory period. This is optimal shortage period, T2. T1 is optimal inventory period. T is optimal, this optimal inventory cycle time. S max is maximum of or shortage level. I max is maximum inventory level. Q star is the optimal order quantity. So the answers are given here. So this one manufacturing model with shortages will study in the production planning course. So then assignment, we have the annual demand for an item for an automobile component is 224,000 units. The carrying cost is 0.40 per unit per year. The ordering cost is 20 rupees per order. And the shortage cost is 10 per unit per year. Find the optimal value of the following: EOQ, maximum inventory, maximum shortage quantity, cycle time, inventory period 1, shortage period 1. So you have to substitute in these formulas. So then you get answers. And the stores management, so the functions of stores, you have receive raw materials, tools, equipments, and other necessary materials and accounts them. Arrange stores to preserve the items in good condition for later use. Maintain proper account on issue of items on demand from shop floor production division. Maintains classification and codification system to minimize obsolescence, surplus and scrap systems. Actually, stores management is a functional discipline is a major thing, in the factory. So it's a big area, and then you have thousands of items in the inventory item categories, and then where the items are located, and when the items are requested for orders, so you have to locate them quickly. So this is actually a huge affair. So income material control, so acceptance sampling for attributes, we can use a quality control method, and then acceptance sampling for variables. And this example, we'll work out, we'll have a break. After the break, we'll work on this example, and I will discuss some exam papers.
Okay, sir. Thank you, sir.
Okay, are you back?
Yes, sir.
We'll work out this example first. So Q star equals, so data, D had D equals 1000. CO equals 100. C C equals 750. So we can find out the optimal load quantity. This is Q star. Q star. Equals 2 times 1000 times CO is 100 divided by 750. So this equals, so you can use a calculator, 2 times 1000 times 100 divided by 750. Square root of this one to the power 5. It's 16.329. So this is 16. Tomorrow quantity 16. So then other questions. What are EOQ and reorder point? Okay. EOQ is 16. So this equals EOQ. Reorder point R. So we need to find R is equals
Recording in progress.
Thousand 60 divided by 1000. So this is in years. So multiply this by 365. So when we find this, so then we get you see 2 times 1000 times 100 divided by 750. The square root of that is 16. Okay. So where have you been? When this comes 16 divided by 1000.
Sir, in previous slide, to calculate reorder point, we have taken it as DL. So why can't we take that part?
I'm going for that. Okay. So,
Okay.
so this is 5.84. 5.8. So you get 5.84 days. The length of one cycle. Okay, so this is length of one cycle. Let's say it is approximately 6 days. Okay, 6 days. Round it out to the nearest integer, and then so better we'll leave it as it is. Okay, so then so this the length of one cycle is 5.84 days. So then you see this cycle is smaller than so cycle. One cycle is small, 5.84 days, but the lead time is longer. Lead time is 7 days. So therefore, in order to receive the order, let's say here, somewhere here, you have to place 7 days here. Okay. So the order has to be placed in order to receive the order in this cycle, you have to place the order in the previous cycle. So this one more cycle is here. So that take that cycle out. So then, we have to take this out. From the 7 days, we have to remove 5.84 days. And from the balance, the balance time is here. And then when you place the order here, you receive the order here. So in order to receive the order here, you have to place the order somewhere here in this cycle. So when you place the order here, one cycle early in the next previous cycle, you have to place the order. So then how much time goes to the previous cycle is 5 point. So then lead time equals 7 days. So therefore, the reorder level equals R equals 7 minus 5.84 multiply by daily demand. Daily demand is 1000 divided by 365. Total value we calculate 7.7 minus 5.84 multiply by 1000 divided by 365. So reorder level is approximately 3.17 units. So that is, when order quantity reaches 3, place an order for 16 units. So this is the answer. So here, first thing is, when you get, when you have to answer the reorder level question, you have to check whether the lead time is longer than or shorter than the inventory cycle time. So if inventory cycle time is Q over D, so if the lead time is less than the inventory cycle time, then when you place the order, you will receive the order in the same cycle. For example, here in this, if you look at this diagram, when you place the order here, let's say somewhere here, you place the order here, let's say the order level is here, and then you will receive the order here. But if the lead time is longer than the cycle time, let's say in this cycle, so if the lead time is less than the cycle time, so when you place an order somewhere here, so this will be the lead time. So from the receive point to the reorder level equivalent time. So that's somewhere here. So then this is less. So, but then if the lead time is longer, so then you have from the lead time you have to remove the cycle time, and for the balance, you have to for the balance time you have to use for reorder level calculation. So the reorder level R divided by this here you have to use this smaller triangle. So this smaller triangle. So then the lead time is here. So this from here to here, lead time. This height is R. Height divided by the lead time equals the slope. Okay, so then the R equals lead times the demand. R equals tau D. So that's the formula. So so then you have to check whether lead time is longer than the cycle time. Sometimes lead time may be longer than let's say maybe 4, 5, 6 cycles. Okay, so then you have to find the relevant cycle by removing number of cycles in between, so that you have to place the order. Let's say when let's say here here you have the cycle time about 5.84 days, and then let's say if you have the lead time equals let's say 20 days, then what happens is so you have in 20 days you have 5.84s. How many you have? 3. Okay, so then the relevant lead time for calculation 3 times 5.84 minus 20. So that means you have 3.8 days equivalence of so then you have to multiply this by D, that's 1000 divided by 365. So this is the reorder level becomes 10. So that's how we do the calculation. So you need to first check this the length of the cycle time. Length of the cycle time here in one cycle is in the lead time you have only one complete cycle. So maybe in the lead time there may be more than let's say more than one cycle, maybe 3, 4, 5, maybe 10, depending on how long the lead time is. So in order to receive items, you have to place the order. Let's say 500 days early. So then, if the lead time is 500 days, so then you have to find how many complete cycles are in the 500 days. 500 divided by 5.84. So then you have 85.616 cycles. And then this one, you need to subtract from this 85. And then you get 0.166, 616. So you have to convert that to number of days. So then you have point. So then 500 divided by 5.84. So then in subtract 85. Multiply this by 5.84. You get 3.6. So equivalent to 3.6, you have to place the order. So 3.6 times 1000 divided by 365. So then the reorder level is 9.86. So approximately to be in the safe side, you can order after 9, when the order goal, the inventory level reaches 9. Or if you're optimistic, then order 10. So that's how we calculate the pre-order level. So I just use the calculator, okay? So slide number 29, okay, so this is a straightforward, just substitute numbers. This one. So for this one, you can use these formulas. So the EOQ. EOQ equals 2 COD. So let me say I am going to use the calculator. So if you can't see the calculator, I will share it. Okay, so then 2 times CO is annual demand for 24,000. Carrying cost is 0.4 units per year. RS 40 cents. RS 0.40 per year. The cost of ordering is 20 rupees per order. And shortage cost is 10. Find the optimal value for following. So 2 times order quantity is you should just substitute these numbers, right? So in the given, write somewhere. COD times CS plus CC divided by CC times CS. The whole thing is square root. So 2 times CO is 20 times D is 24,000. So within bracket C is 0.40 plus CS is 10. Multiply this by 2 times 20 times 24,000. 10.4, we get 10 plus 0.4. Um, then divide this by 0.4 times 10. Get that number and get the square root of it. You get 1579 units. So the optimal order quantity is 1579.87, that is 1580. So for this the answer is 1580. So again, to the answer, I'm going to calculate again. 2 times CO is 20 times 24,000 times 0.4 plus 10 divide this by CS is 0.4 CC times CS is 10. To get that and take the square root of it, we will get so that amount. So I got 1579.87. You see 24,000 again, let's say 2 times 24,000 times CS is 0.34, 0.4 plus 10 divide this by 0.4 times 10. Let me just say 2 times 24,000 times 20 times 10 plus 0.4. Divide that by 0.4 multiplied by 10 square root of that is. So 1580 is correct. So 1549 is incorrect. So answer is 1580. So then maximum inventory level again, we can substitute in the formula. So Imax equals to CO D times CS divided by CC times CS plus CC square root of that. So Imax, we can calculate 2 times CO is 20 times 24,000 times CS is 0.4. So CS is 10. 10. Divide this by this is 0.4. CS plus AC is 10.4. So 2 times 20 times 24,000 times 10 divided by C is 0.4 times 20 times 4,000 times 10 divided this by CS is 0.4. CS is 0.4 times CS plus C is 10.4. With that number and then the square root of that, 3.5. With 1,590. This is crazy. So you see CO equals to how much? CO equals 20, in the question. Why don't you read the question? CO equals 20, CC equals 0.4, CS equals 10, D equals 24,000. So these numbers, you just have to substitute the numbers in formula. So it's, it's very difficult to write down these numbers here itself. It's a So we got Imax for equals 1,519. S max equals, you see, 1,580 minus 1,519. So this 61. So this equals, question is equals 1,580. This equals 1,519. This equals 6. Q star over D. We can calculate Q star over D as star is 1,580 divided by 24,000. So this equal point, see that many years. So in days, you have 24 days. Convert into days, 24 days. This is maximum inventory time. $1,519 divided by 24,000. Multiplied by 365. 23 days. So this is equals 51 divided by 22,000. One day. So maximum shortage time is 1 day, and inventory time is 23 days. The cycle time is 24 days. Maximum shortage is 61 units. Maximum inventory level is 1,590. Order quantity is 1,580. So this is how we get the answer. And I'm going to so this the last examination question. A manufacturer requires a particular electric wired subassembly. Please read this question. Yeah, okay, find the economic order quantity, reorder level, and the total annual inventory cost when the item is purchased. So, actually we need to write down data. Annual surplus demand is 480. B equals 480. CO equals 85. Carrying costs are 75% of the average inventory investment, and budgeting cost 1,125. Carrying cost CC equals 0.75 times 1,125. So this becomes 43 point. So we can use the formula to order quantity Q star two times B 480 times 85 divided by 843 point 75. So we get this number 2 times 2 times Hmm. 9.83, so approximately 10. Okay, 10 bundles is the answer. We have to find reorder level. Reorder level, before we find the reorder level, we need to find the review period. Review period equals Q star, that's 10 over 4 into. So this equals so in the question, we have the method of production, and so we have the working days, 250 working days, okay? So this is years. This is QOD is 10 over 4 multiplied by 250. You get 5.20 days. 5.20 days. And the lead time, so this is 5.20. The lead time we have lead time is 21 days. So lead time is longer than lead time is longer. So we need to calculate how many days are, how many cycles are in the lead time. So 21 divided by 5.2. You get 4.038. So minus 4. multiply with 5.2. You have 0.2 days.
Sir, excuse me, sir. Can you explain that part again, sir? The last part.
So the review period is, review period equals 10 divided by 480 in years. And then here, in this question, we have taken working days, number of working days, 250. Right? So
Okay.
here,
Yes, so that part is clear, sir. The next one. 21
then,
divided by 5.2.
okay. So then, we got 5.2 days. So the work, review cycle equals 10 divided by 480. So then that's when you multiply by 250, you get 5.20. So if you multiply by 365, you get 7.60. Okay, 7.60 days. Some students have answered with 7.60 days also. So in that case, I cannot answer. So let's say we take 5.2 days, 5.2 working days. Okay. So then you have 20, the lead time is 21. So lead time is longer than review cycle. Okay. Review period. So therefore we need to check how many complete review periods are there in the lead time. So in the lead time you have 4.038. So when you divide 21 by 5.2, you get 4.038. So you have 4 cycles. So then from the lead time, you take 4 cycles out. So then, there are 2 ways of calculating, the relevant time for reorder calculation. So one method is, you subtract 4 and then 0.038 multiply this by 5.2. You get 0.2 days, you get. On the other hand, there is a possibility you can multiply by, from 21, you can multiply minus 4 times 5.2. Again, you get 0.2 days. So then 0.2 minus multiply by 480. You get 96 as the reorder level. 0.2 is multiplied by 0.2 multiplied by 480. Divide this by 250. You get 0.384. So actually, when this is, so in this answer, when the reorder level, when the order quantity reaches, let's say near 0, let's say 0, you place an order. Okay. So the reorder level equals 0. Equals 0 in this way. On the other hand, you can also use the other answer is if you use 365 days, 365 days. 10 divided by 480 multiplied by 365. You get 7.60 as the review cycle, okay, review period. And then, you can check how many come between 21 days, how many 7 point get 2.76, and then that's 2. So 2 times 21 minus 2 times 1.6, get 5.8, multiply this by 80, divide this by 265. You get 7.62. So this is 21 minus 7.60 multiplied by 5.8. And when this one is multiplied by the demand, that is 480 divided by 265. You get 7.62. So that reorder level is approximately 7. If you round it off near to the 8 units. So the other answer is review period equals 7.60. Then reorder level equals 18. So that's the both answers are correct. Okay, both answers are correct. And then total cost, we need to find the total cost. Total cost equals you see can you see the calculator?
Yes, sir, we can see that.
Okay, so then you have 21 days. In 21 days, first thing you have to divide 21 by 5.2. We get 16.21 divided by 5.2. We get 4.038. So we have in the lead time, you have 4 complete review cycles. Okay, 4 periods. So you have to take that out. So then from 21, you take 4 times 5.2 out. What remains will be 0.2 days. And then 0.2 days, 0.2 multiplied by the demand per day. So demand per year is 480. Divide by this by 365. You get 0.26. So this 0.26 is approximately 0. That's why I put that as reorder level as 0. Okay. So, but then when the reorder level is 0, you place the order at the beginning of the relevant cycle. At the beginning of the, you have to place the order 4 cycles ahead. Let's say 21 days. 21 days. You see, 21 days approximately falls on at the beginning of a particular cycle. That cycle, from that cycle to order receipt cycle, you have 4 cycles, 4 complete cycles. So that's how it is. And then the total cost, we have to we can substitute in the formula. Total cost equals you see plus EC plus function is C D plus divided by Q. This is IC is point. IC equals CC times Q divided by 2. So when you substitute in we can use the calculator. So then you have CO is 85 multiplied by D is 480 plus C is 1155 times D is 480 plus IC is 0.75 times So there's a mistake. So we need to CO is 85 times 480 divided by 10. Q is 10 plus 480 multiplied by 1125 plus 0.75 multiplied by 1125 multiplied by 10 divided by you get 548,000. So it's 290. Five hundred and 48,000. So then for the second section, Q star equals Q star So when you substitute here, 2 times CO, CO is 30, D is 480, CC is 0.75 times 1125. Mhm. 0.75 multiplied by 1125. This 480. Production rate is 1000. Production rate is given. This will be currently okay, and cost per item is okay. It can be delivered when they produce. Ordering cost 30 per order, and per item. Okay. You see, the method of production under investigation produces maximum of 4 buns per day over 250 days a year. So that is 1,000 buns per year. So that's why production rate is 1,000 here. So when we simplify this one, you can substitute, 2 times 30 times 480. Divide this by 0.75 multiplied by 1,125 times 480. If we fail to multiply by 1,125, so we need to start again. 2 times 30 times 480 divided by 0.75 multiply by 1,125 multiplied by 980. This one is with 8.10. That's approximately 8 units. 8 units. So then we have to answer pre-order level. So that then we have to find review period. Review period equals Q is 8 divided by 480. So this equals times 250. You get 4.16. That is 4.17 days. And then, the lead time in this situation. You see, alternator manufacturer is considering setting up bundle. Okay, this would bring a 480 current purchases in-house. And the method of production and the investigation produces 4 bundles. Cost per item and can be delivered when they are produced. Okay. Rather than in the previously determined lot size, ordering cost 4 to 30, while okay, remaining item cost and all fixed. So either case, we have to take the lead time as 21 days. So therefore, we have to check how many days are there in 21. So you can divide 21 divided by 4.17. you get 5.03. You have five complete cycles. So 21 minus 5 times 4.17. You get 0.15. Multiply this by 480. Divided by 250. Reorder level again, this situation, reorder level is 0. Equals 0. So if you use the 250 days, but if you use 365 days, so then review period becomes 8 divided by 480. So then multiply this by 365. So then you get 6.08. Review period. You get 6.08. And then reorder level. Equals. You see, you divide 21 by 6.08. You get 3.45. So you have to subtract 3 cycles. 3 times 6.08. You have 2.76 days for the calculation. So this multiply this by 480. Divided by 365. So you get 3.6. So reward level equals 4.
So if we take 250 days, the answer is not 0, sir.
When for 250 days?
Answer is not 0. Previously, you told that.
Okay, so let's say, calculate. You have 21 divided by 4.17. Okay. So then you get 5.03. So you have complete 5 cycles. So then I'm going to subtract from 21 5 times 4.17. So you have 0.15 days is the the number of amount of days that we need to use for calculation of the reorder level. So 0.15 multiplied by daily demand is 480 divided by 250. So you get 0.288. So 0.288, you have to round it up to the nearest integer, that's 0. That's how we got the reorder level 0. In the other situation, we get 8 divided by 480. So this many, this is years. So multiply this by 365. You get the review period that equals 6.08. And in this one, how many days sample, how many 21 divided by 6.08 You have 3 complete cycles inside. So then these take these 3 complete cycles out. 3 times 6.08. So then you get 2.76. So then this multiply this by 480 divided by 365. You get 3.62. So I rounded up to the nearest integer. So then I get 4 units as the pre-order level. And then, we can calculate the total cost. Total cost equals so there's only one exception. In this one, we have 1 minus DOP. See, mhm. So but here there is another issue. We need to check, view period equals 4.17 days. And then production time. So then, the remaining time, of course, let's see, production time. Equals Q over D. Q OP. So this equals Q is 8, P is 30,000. Multiply this by say 650. So 2 days. 2. And then for so non-production time is this is 2 days. Non-production time is time equals 2.17 days. And then the remaining time in the, so let's say remaining time after, when you take 21 minus 5 times 4.17. 0.15. So answer is okay. But if it is larger than 2.17, then you see our answer is going to be using the other triangle. Production, the production happening triangle is the one that has to be. So in this case,
Here, when we deduct 5 from 21, the answer is 16. When we multiply 16 by 4.17, the answer is not that, sir.
you see, this 5 point, 5 I got, by 21.
Minus 5.
No. 21 divided by 4.17. In that, we have the numerical value.
Okay,
is
sir.
5. So
Right,
this
that
5,
is correct, sir.
this
But
5 that I subtracted from 5 times 4.17. So that's 0.15.
So if you put a bracket like that, 21 minus 5, the answer is 16. 16 multiplied by 4.17, the answer is 66 like that. So
No,
is it wrong?
You have to subtract the complete length of the complete review cycles.
Right. Okay, sir. Right. Got the point, sir. Thank you, sir.
So then in the second case, review period is 6.08 days. So reorder level, we have to check it. So production, let's say production time. Production time equals Q over P. Q is 8, so then it's the same. So it's 2 days. We are using 365 now. So it's going to be different. So 8 divided by 1000 multiplied by 365. You get 2.92. 92. Then non-production time time equals 6.08 minus 2.92. So this equals 3.17. Now you see we have to calculate, 21 divided by 6.08. You get 3 complete cycles. So in that, then 21 minus 3 times 6.08. You get 2.76. Since 2.76 is less than 3.17, still we have to use the same triangle where, the triangle where non-production time occurs. Otherwise, we have to use the other triangle for calculation. So in this case, 3.17 multiplied by 2.76. 21 minus 6.08. 21 minus 3 times 6.0. 2.76 multiply this by 480. Divide by 365. We get 3.629, so it's 4. Then reod level is 4. Equals 4. Then we need to substitute in this formula the total cost. So when you substitute, you get so then I substitute here. CO is 85 multiplied by D is 480 divided by Q is 8 plus D is 480. There's a mistake. CO is 30 multiplied by D is 480 divided by 8 plus D is 480 multiplied by 1125 plus IC is I is 0.75, C is 1125. Within brackets, we need 1 minus 480 divided by 1000. Bracket closed. Multiplied by 1125 multiply by 8 divided by 2. Get 543,000. 43,000 something. 555. So then, so the final answer, what would you recommend purchase or produce? Why? What for qualitative factors did you consider in this condition? So here, one thing is total cost of purchasing is greater than total cost of producing. So then we have one observation is it is cheaper to produce than buy. So that's one thing. The other thing is, you see, the very fact that you have due to the fact that in-house production is activated, supplier dependence is minimized. So this is the one thing. The other thing is see, we get train we get train start in the factory. So due to these things, you better better to produce. So this is my answer. See, when you write, of course, it's not going to take much time. Here we write typing in the computer, it takes a lot of time. By handwriting, you can easily work this thing out. So, but then, one thing I must mention in this reorder level calculation is this is so, we need to check where the order point falls, Let's say in that example, fortunately, when we take the number of cycles out, the remaining time part fell somewhere here. So that, we use this, let's say if it was here, then, we have to use the remaining time is this much. and then reorder level is that much. So then R divided by this much equals the slope of this one. Okay. So that's why we multiply by the demand rate. Otherwise, let's say if it falls somewhere here, let's say the reward level calculation, then we have to use this triangle. And then in order to find this triangle, the remaining time, if we get the remaining time longer than the non-production time, then we have to subtract from review period time the remaining time, and then from that particular time we have to multiply that by P minus D, not by D. Then we get the reorder point. So this is what we need to observe. That's why I again double check the answer for the two occasions when I divide by 365 or 250. Okay, so yeah, we are now done. We have done 4 hours. So I'm going to end the class. So we'll see you next week.
See you, sir. Good night,
Okay.
sir. Okay, sir. Thank you, sir.
Okay, thank you, sir.
Thank you, sir.
Thank you,
Thank
sir.
you.
Recording